Welcome to e-learning videos. In these videos, we are going to learn about nitrogen compounds, the major functions of protein in the body, the hydrolysis reactions of protein, the primary, secondary, tertiary, as well as the quaternary structure of protein, and also the types of chemical bonding that's involved in this type of bonding, and lastly, the denaturation of protein by various methods. Let's first look at proteins, its functions and importance in our body. Proteins are very large organic compounds. They are made up of many multiple amino acids. They are joined together by peptide bonds or amide linkages. They are very essential components of all living organisms and have various important biological processes. The main functions of proteins are stated below, mainly structural support, storage, transport, movement, immune system, digestion, messengers, as well as receptors. You are required to list down all these functions if they are being asked in exams. To find out more about the various properties of these proteins, please take a look at the video below. Let's now look at the hydrolysis reactions of proteins. Proteins contain peptide linkage or amide linkage that can undergo acid-base hydrolysis to give back their constituent amino acids. They are often hydrolyzed using acids as shown below. In the process of hydrolysis, the amide linkage, which I'm going to highlight in yellow, is going to be broken down to give back the constituent amino acids, in this case which is glycine and aniline. Remember that proteins are made up of amino acids, mainly alpha amino acids, by the combination of their carboxylic acid end together with the amine end of another amino acids to give the corresponding peptide. In this case, upon hydrolysis, there will be a breaking of the carbon and nitrogen bond to give back the corresponding amino acids with the carboxylic end being restored. However, you do not get back an amine for the other amino acid because since this condition is acidic and the amino acid with the nitrogen group contains a lone pair, it will pick up one of the H plus to give you a protonated amino acid. Let's now look at the conditions for the hydrolysis of proteins. We can carry out the hydrolysis by using either one of the two ways, which is either using 6 molar per dm cube of HCl for about 24 hours at 110 degrees Celsius, or by placing them in 6 molar per dm cube of hydrochloric acid in an atmosphere of nitrogen and in an oven for about 5 to 30 minutes at a temperature up to 200 degrees Celsius. It is useful for us to note that these conditions are quite strenuous, which explains why our DNA is mainly made out of peptide linkages, as we wouldn't want our DNA to undergo hydrolysis easily. That concludes our first video. Please go on to the second video to learn more about protein structures.